Hi and welcome, I'm Gavin Lon. This is the 11th and final part in a series of videos dedicated to building a shopping cart application using Blazor WebAssembly and Web API on .NET 6. So, we have now built our basic shopping cart application. But is software ever really 100% complete? At points there may be bug fixes to make. We may need to upgrade our application with the latest technologies. A requirement may arise to improve the overall performance of the application. There may be parts of the application where UX, user experience, can be enhanced. In this video, we are going to look specifically at how we can improve the performance of our application by optimizing our code. There are two areas where we can potentially enhance the performance of our application. Item number one, in the Web API component, we are currently making two separate queries to the database when retrieving product data. Our code is returning both product data and product category data to the calling client. To do this, we are currently calling two separate methods in the product repository class. One for retrieving details about the products from the products database table, and the other for retrieving details about the product categories from the product categories database table. So in this video, to potentially enhance performance, we are going to retrieve the product and category details through one query to the database instead of two. The other area where we can improve performance is by using local storage within the Blazor component to store both the product data and shopping cart data, so that when our application needs to retrieve relevant product data or shopping cart data, our code can retrieve the relevant information from local storage, i.e. data stored on the client within the user's browser, as opposed to making a trip, as it were, to the server every time the relevant data needs to be retrieved. So basically, the travel time in retrieving the relevant data can be shortened in certain scenarios. The data can be retrieved on the client instead of the server. For content like this and much more, please consider subscribing and please ring the bell so as to be notified of future content. If you like this video, please hit the like button and please feel free to share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage. Any support is greatly appreciated. So let's attack the first item. Let's go to the shoponline.api project. Let's optimize the code on the server where we can make one query to the database to retrieve both product information and related product category information, rather than use two separate queries for this purpose. In the comments, I was asked why didn't I code the functionality for retrieving product data and related product category data using one query. This, of course, is a great question. The reason I did this was because at the time I was focusing on the repository design pattern, DTOs, and separation of concerns. I wanted to keep the code at that stage as simple as possible so as to focus on those concepts. I didn't want to go off on a tangent regarding relational database concepts. I had been more thorough in explaining relational database concepts in the MVC course, so please check out the MVC course if you haven't yet done so. I wanted to keep this course more focused and simple. In hindsight, I think I should have initially optimized the relevant code using one query, because as you'll see, the code for this is actually quite basic. So the first step is that we need to modify the class representing the product entity. So we must first add a public property to the product class that is of type product category. Let's add the foreign key attribute to our new product category property. We can then pass an appropriate string value to the foreign key attribute that is used for declaring which property in the product class must be used for joining the product entity to the product category entity. So this code will indicate to EF core, as it were, how we want to join the product entity to the product category entity. Let's go to the product repository class and first modify the getItem method to appropriately join the product entity to the product category entity in the relevant LINQ query. So to do this, we can use the include method like this. We are establishing the join between the two entities through this lambda expression. Notice the product category property that we recently created within the product class. For this query, we only want to retrieve one item, so we can use the single or default async method to filter the product data based on the relevant product ID passed to this method. Then for the getItems method, the code is similar to the getItem method. But for the getItems method, we wish to return all the products that are currently stored in the products database table with the related product category information to the calling code. So we of course don't need to filter the data. So that means we don't need to use a method like the single or default async method in this query. Then the last method that we need to appropriately modify is the getItemsByCategory method. If we open the product controller class, we can see that we can now simplify the code here, but first we need to appropriately update the relevant extension methods responsible for converting objects of type product to objects of type product.DTO. So let's first update the extension method that converts an individual product to type product.DTO. Great. Then let's update the conversion extension method that converts a collection of objects of type product to a collection of objects of type product.DTO. Great. We can now update the relevant action methods accordingly. We no longer need to query for the category items in a separate query that we are using here to get a collection of category items. So we've potentially improved performance of the server-side code through an appropriate code optimization exercise. We are only dealing with a small amount of data, so the performance improvement would probably be negligible. But if we were dealing with large amounts of data, the performance improvement would be more significant. So let's look at the second way that we can improve the performance of our application. The second way that we can improve the performance of our application involves an update to our Blazor component. So let's go to the shoponline.web project. Let's see how we can reduce the number of trips to the server we are currently making for retrieving relevant product and shopping cart data through the use of local storage. So we could use JavaScript and Blazor's JavaScript interoperability feature and write our own local storage functionality. It turns out, though, we don't need to go to this kind of trouble, because someone has already made available a NuGet package that contains the local storage functionality we need. So let's invoke the NuGet Package Manager window. Let's search for local storage. And this is the package we want to install. So let's install the Blazored.LocalStorage NuGet package. For more details regarding local storage, please navigate to this URL. Basically, the JavaScript local storage object allows you to save key value pairs in the browser. Note, the local storage object stores data with no expiration date. The data is not deleted when the browser is closed and are available for future sessions. So the local storage functionality provided to us within the Blazored.LocalStorage NuGet package abstracts the JavaScript code for managing local storage. So we don't need to write the relevant JavaScript code ourselves. We are now going to create two services to encapsulate our local storage functionality. So let's first create an interface named iManageProducts Local Storage Service. Let's create two method definitions, like this. Let's create an appropriate method definition for a method named getCollection. Let's create an appropriate method definition for a method named removeCollection. Let's create an appropriate service class to implement the methods defined within the interface we have just created. Let's create a constructor whereby we indicate that we want an object of type iLocalStorageService and an object of type iProductService injected into our constructor at runtime. Note that the iLocalStorageService type is a type provided by the Blazored.LocalStorage NuGet package that we have now installed. So this type will be used to implement the necessary local storage functionality. Let's create a private method named addCollection. This method simply retrieves the product data from the server and saves the relevant product data in the user's browser using local storage. Okay, let's create a string constant to store the key that will be used to identify the relevant value. In this case, the relevant value is a serialized collection of objects of type productDTO. Let's implement the code for the getCollection method. So this method first tries to retrieve the relevant data from local storage. If the relevant data does not exist in local storage, we can call the addCollection private method to retrieve the relevant data from the server and save the relevant data to the user's browser using local storage. The remove collection method simply removes the relevant data stored within the user's browser using local storage. Right, let's create an interface within the contracts folder named I manage cart items local storage service. Let's create an appropriate method definition for a method named getCollection. Let's create an appropriate method definition for a method named saveCollection. Let's create an appropriate method definition for a method named removeCollection. Right, let's implement the relevant code for the interface that we have just created. So let's first create a class named Manage Cart Items Local Storage Service. Let's create a constructor whereby we indicate that we want an object of type iLocalStorageService and an object of type iShoppingCartService injected into our constructor at runtime. Let's create a constant to store the key that will be used to identify the relevant item stored using local storage. The local storage item in this case will be a serialized collection of cart item DTO objects. Let's create a private method named addCollection. This method simply retrieves relevant data from the server and appropriately saves the data to local storage. This method attempts to retrieve the relevant data from local storage. If the relevant data does not exist in local storage, the code retrieves the relevant data from the server and appropriately saves the relevant data to local storage. Let's implement the code for the removeCollection method, which involves appropriately deleting a collection of objects of type CartItemDTO from local storage. Notice that the key constant is used to identify the relevant local storage item. Let's implement the code for the saveCollection method, which involves appropriately saving a collection of objects of type CartItemDTO to local storage. So we haven't yet registered the iLocalStorage service type provided in the Blazored.LocalStorage package with the dependency injection system. So let's open our program.cs file and apply the code to register the iLocalStorage service type for dependency injection. So we can use the add Blazored local storage extension method for this purpose. We must then also register our two new service classes that we have created to abstract the relevant local storage functionality with the dependency injection system. So let's now implement the relevant local storage functionality within the relevant Razor components in order to hopefully increase the performance of our Blazor component. Let's open the product's base class. This is the base class for the Razor component that first loads when our application is first launched. Let's create the code to ensure that our two local storage services are injected into this Razor component. Let's say that when the product's Razor component is loaded, we want to clear the relevant local storage items from local storage. This will force our code to retrieve the relevant data from the server at this stage. So we want the relevant data retrieved from the server when our application is first launched. Then subsequently, we want the relevant data retrieved from local storage to enhance performance. So let's create a private method named clearLocalStorage and use the relevant functionality we have created within the relevant services to remove the relevant data from local storage. Let's call this method from within the onInitializedAsync method. Then instead of going straight to the server for our data, let's use the appropriate local storage service object to first check to see if the relevant data resides within local storage. Of course, in this case, we are clearing the data before this method is called, which will force our code to retrieve the data from the server. However, our code will subsequently save the data retrieved from the server to local storage, which means that when other Razor components retrieve the relevant data, the data will be retrieved from local storage on the client's side, which means an unnecessary trip to the server will be avoided. So this gives us an idea of how we are able to increase performance of our application using local storage. We can also use our Manage Cart Items Local Storage Service object to retrieve any cart item data that may be saved to the user's shopping cart, like this. So in this case, this code will retrieve the relevant data from the server and save the data to local storage. Any data retrieval of items within the user's shopping cart can then be done from local storage, and therefore trips to the server are saved and the performance of our application is potentially enhanced. Let's appropriately update the shopping cart Razor component. Let's write the code so that an object of type iManageCartItems local storage service is injected into this Razor component at runtime. In the onInitializedAsync method, let's replace the code that retrieves the relevant cart item data from the server to get the relevant data from local storage. When a user updates the quantity of a particular item saved within the user's shopping cart, we must update the relevant local storage item. This is because, of course, the relevant shopping cart has now changed. We can appropriately implement the save collection method for this purpose. We must also use the appropriate local storage service to implement the code to update the relevant local storage item when a user removes an item from the user's shopping cart. Let's implement the relevant local storage related code for the product details Razor component. So this component is responsible for displaying details for a particular product. This Razor component also contains functionality for adding a product to the user's shopping cart. Let's first create a private property to reference the shopping cart items collection here, because when the user adds a product to the user's shopping cart, we want our code to update the relevant local storage item. We no longer only want the code to update the relevant shopping cart on the server. We need to keep the client-side local storage data up to date as well. So let's first write code to update our shopping cart items private property with data retrieved from local storage within the onInitializedAsync method. So within the method responsible for adding a new item to the user's shopping cart, we need to write code that not only updates the data on the server, but also updates the relevant local storage item. So we can implement the desired functionality in code like this. We can also now implement code that gets data for an individual product from local storage. Great. Let's appropriately update the products by category Razor component to include local storage functionality. Let's write code so that an object of type iManageProducts local storage service will be injected into this Razor component at runtime. Let's write a private method so that the products filtered by category ID are retrieved from local storage. Let's appropriately call our new private method from within the OnParametersSetAsync method. Lastly, let's appropriately update the checkout Razor component with our local storage functionality. Great. Let's run the code. Excellent. That definitely seems to have made a positive difference to the performance of our shopping cart application. If you've made it to the end of this course, well done! You have learned quite a lot about Blazor WebAssembly and Web API. We have also learned how to create a basic SPA application where the vast majority of the code is implemented using C#. I hope you have enjoyed going through this course as much as I enjoyed creating it. For content like this and much more, please consider subscribing and please ring the bell so as to be notified of future content. If you liked this video, please hit the like button and please feel free to share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage. I've also included a PayPal Me link that you can use to support the channel via PayPal. Any support is greatly appreciated. A special thank you to those who have been kind enough to support the channel. It is greatly appreciated. I really enjoy engaging with you in the comments section, so please feel free to leave a comment. The latest code can be found on GitHub. A link to the relevant repository has been included below in the description. Thank you and take care.